We're asked for the second derivative of this parametrically defined curve. So there's the notation looks a little intimidating probably for second semester calculus students, but it's really not that bad. You want to find the derivative of y and the derivative of x. And then once you've done that, and you want to just take a derivative of that result. That's what this says. So find dy dx just like you would a first derivative of a parametric relationship, and then take the derivative again with respect to x. Or in other terms, and just putting things in terms of dt, we have this notation over here. They're equivalent. So you can find the first derivative, and then take a derivative with respect to t. And then once you've done that, divide it by the result you got when you took a derivative of x with respect to t. So all these rely on the derivative with respect to t. Let's start with that. So the derivative of x with respect to t is 4t to the first minus 4. The derivative of y is 12t squared plus 12t plus 4. Just making sure. Yep. Okay, so that's the derivative, and so the numerator of the second derivative should be a derivative with respect to t of dy dx. So we need dy dx first. Remember we said dy dx from a previous video was the derivative of y with respect to t divided by the derivative of x with respect to t. So the numerator of the second derivative says you got to take a derivative with respect to t again. So dt of that dy dx needs the quotient rule. It's the derivative of the numerator times the denominator kept the same minus the numerator kept the same So I had to cut the video because right here I made a mistake when I first did this problem. I didn't multiply by the derivative, I just multiplied by the entire denominator. So I messed up the quotient rule. Okay, and the denominator in the quotient rule is the denominator of your original expression squared. So that's the derivative with respect to t of the first derivative. That's this part in the second derivative formula. We need to divide it by the derivative of x. So if I'm going to divide, it's the same thing as flipping and multiplying. So I'm going to have 4t minus 4 to the third in the denominator. And while we're at it, let's distribute the numerator and simplify, see what we can simplify. So 24t times 4t is going to give us 96t squared. And then 24 times 4, see, that's 96. Oh, that should be a minus 96. Wouldn't want to have to remake the whole video again. 12 to 4 is 48t. I'm just multiplying these parentheses. 40 minus 48. And then this is 4 times everything, so that's going to be minus a 48 t squared. And then that's 48, so that's minus a 48t. And then minus 16. This is all 4t minus 4. Oh, sorry. Yeah, squared. Okay. And I getting ahead of myself. I was talking about the second derivative total. This is all still the derivative of this, with respect to t. This is all the numerator. If we want it to be the second derivative, then we need to divide it by what, like I was saying, the derivative of x with respect to t. So the only thing that's going to be different is this is going to have to the third power in the denominator. Okay, because you're dividing by 4t minus 4, so that's the same thing as flipping and multiplying. So in the numerator, if I can clean that up, that's 48t squared. And then my mental math is not so good today, so let's double check this. Did I distribute that correctly? Minus 48, yeah, so that should be minus, looks like minus 96t. So positive 48 minus 48, yeah, that makes 96. And then minus 48 minus 16, 50, that's 64. Okay, let me pause here and see if Newton accepts this.